Welcome to June's Leetcode Challenge. Today's problem is min cost climbing stairs. You're given an integer rate cost, where cost I is the cost of the ith step on a staircase. Once you pay the cost, you can either climb 1 or 2 steps. You can either start from step with index 0 or step with index 1. Return the minimum cost to reach the top of the floor. So here, with this example, we have 3 costs, 10, 15, 20. We can start at either the first or second step here, and we want to reach the end, the very top, which is actually not shown inside here, but like say that we get to this step, the second step, then we can take 2 steps and get out of the staircase to the very top. So that would mean the minimum cost here would be 15. Okay, so the approach here is very clearly dynamic programming solution. We can certainly write a recursive solution starting from the top down, but because the dynamic programming approach is so obvious, I think we can just skip that. Say that we had this step here, right? We begin with these 2 steps. What is the cost of getting to these 2 steps here? Well, it's just going to be what the cost is. Like either step we want to get to, it's going to be 1 or 100. We start from like a step that doesn't exist, and we can either go here or here. So that's obvious. Like we can't change anything there. What about this third step here though? Well, we know that the cost is going to be at least 1, but we're going to come from either this step that comes before or a step that comes 2 steps before, either this 1 or 100. So which one do we want to come from? Well, obviously the one with minimum, right? So what we'll do is take the minimum between these 2 and add it to this cost here. So that's going to be a 2. Now all it is just iteratively going up. Like what's the minimum between these 2? Well, it's 2, and we add that here, and it's going to be 3. What about here? It's going to be 2 or 3, so we add 3. Here it's going to be 103 no matter what, and here we say it's going to be 4 or 1, or I'm sorry, 103 or 3. 3 is going to be minimum, so we add 1 to 3. Then here we add 1 to 4, that's 5. Here it's going to be 104, and here finally we take this step here, which is going to be 6. So basically we want to take the minimum at this point between these 2 steps here, because we can certainly add 1 extra like space here for a dynamic approach solution, but I don't think that's really necessary. We just need to take whatever is the minimum between these 2 and say, well, that's going to be the number that takes cost. So that's going to be 6, and the answer is, you can see, 6. All right, so we can see that the length of the stairs are going to be at least 2, so we don't need to worry about edge cases. So let's begin. Let's create a dynamic DP array, and we'll just first initialize all of these to 0 times, let's see, we'll call n to be the length of cost. So 0 times n. Now we need to set our base cases, dp0 and dp1, and that's just going to be equal to cost of 0 and cost of 1. Oops. Finally, let's iterate from I to the range of 2 to n. We are going to take the minimum from our previous 2 and add it to whatever the cost is right here. So dpi is equal to cost of I plus the minimum between dpi minus 1 and dpi minus 2. Oops. Finally, we just want to return the minimum between dp, let's see, the last 2 objects. So I believe that's -1, like this. And that should be it. So let's make sure this works here. This should be 15. Oh, okay, minimum cost. Oh, my mistake, times n. Let's try that again. Okay, so that didn't work. What did I do wrong here? Okay, dp minus 2. Yep, wrong again. Is that -2? Okay, so I think that's right, so let's go ahead and submit it. And there we go, accepted. That's great. So time complexity is O of n and O of n space because of this DP array. But I think you could quickly realize that we don't actually even need an entire array here. We just need the 2 previous spots. So to do that, we can just get rid of this DP array. We can just say previous 2 steps behind is going to be that first step, and previous 1 is going to be step right behind. And what we can do, instead of having this DP, we'll just take our previous 1 and previous 2. But make sure to update it. Oh, wouldn't be this right here. This would be, I guess, temp. And previous 1 is now, well, actually, previous 2 should now equal previous 1. And previous 1 now equals temp. And finally, return the minimum between these two. And that should be the same. Let me make sure that works. Looks like it's working, so submit it. And there we go, accepted. So this is O of n time complexity, but O of 1 space, constant space. So that's it. All right. I think this is a pretty traditional problem. Hopefully you guys understand it and we'll end it there. Thanks for watching my channel. Remember, do not trust me. I know nothing.